Hi, welcome up to our team's OpenVAS remediation plan. My name's Nate Spinks. The team also consists of Alec Henning, Cassidy Spencer, and Galen Forbes Roberts. So in our presentation, we're going to be talking a little bit about the tech overview of the technologies that we use to conduct this scan. We'll have a short OpenVAS demonstration video, followed by the top 10 vulnerabilities or classes of vulnerabilities that we identified on the machine that we scanned. And then we'll talk about the remediation actions of, how do we go about fixing these vulnerabilities? And then we'll have a little conclusion section at the end where we talk about where does the machine now stand and what are kind of the limitations of a scan like this and our analysis. So let's get into it. So for the technologies that we use, VirtualBox is our hypervisor that manages our Kali Linux machine where OpenVAS is being run from. And it also is the hypervisor that's going to host our hack target, which is the Metasploitable 3 box, basically. So the purpose of what we're going to be doing is conducting a scan with this Metasploitable 3 machine as our target, and then we're going to identify and fix vulnerabilities based on what OpenVAS tells us to do. So to talk about OpenVAS just a little bit more, or Greenbone Security Assistant, OpenVAS is the Open Vulnerability Assessment System, which is this originally open source project that is a framework for vulnerability scanning and identifying what you need to do with those vulnerabilities. So kind of the difference between OpenVAS and Greenbone is that there was a copyright issue that arose a number of years ago, and Greenbone became the sort of commercial front-facing name for OpenVAS. So OpenVAS is still available as an open source project, but if you want to use it commercially for enterprise purposes, there's both, for their products, they have Greenbone Security Assistant, or GSA, and Greenbone Security Manager, which is GSM. And with that, I'm going to hand it off to Alec Henning, who's going to talk about the demonstration that we have and the top 10 vulnerabilities.
Thank you. Like Nate said, we're going to watch a brief demonstration of OpenVAS capabilities now. Hello, everyone. Today I'm going to be doing a brief demonstration of the OpenVAS scanning capabilities and results. I'm already on the dashboard now, so let's go ahead and take a look at the scan section. If we scroll down, we can see that there's been multiple scans already completed. So let's go ahead and take a look at the Metasploitable 3 scan configuration. For our scan target, we are scanning Metasploitable 3. We've set the minimum quality of detection to 70%. The scanner has been set to OpenVAS default, and scan config is full and fast. So let's go ahead and get out of this. And if we click the number of reports here, we can see that there's been 2 reports or 2 scans that have been completed on this machine. So let's just click this one and take a look. If we go up to the top here and click corresponding results, we can see a nice pie graph and bar graph of the actual scan results. In this case, the scan says that we found 45 high, 120 medium, 14 low, and 133 log results. Okay, so let's go ahead and go back and click the results button. Here we have the entire list of results that have been found during the scan. Right now they are sorted by severity. And if we take a look at these here, we can see that multiple results correspond to the same application. So for our list of top 10 vulnerabilities, we took this into consideration and consolidated those related vulnerabilities. Let's go ahead and take a look at one of these vulnerabilities here. Get a lot of information, such as the summary, detection results, insight. Most important probably is the impact. This one here says that successful exploitation will allow remote attackers to run arbitrary code. Probably going to want to take care of that as soon as possible. Well, that's all for this demonstration. Thank you. All right, so after that brief demonstration, let's go over the top 10 vulnerabilities that we discovered. So if you recall from the video, these were the scan results for our Metasploitable 3 machine. There were 45 high, 120 medium, 14 low, and 133 log results. These severity ratings are determined using the National Vulnerability Database, or NVD, and the Common Vulnerability Scoring System, CVSS. And there are multiple factors taken into account when evaluating severity ratings, such as the attack vector, attack complexity, the scope, integrity, availability, etc. Please note that the vulnerabilities should be tackled by order of their severity. This is the top 10 vulnerabilities we discovered during the scan. Note that they're in no particular order and all of them pose a significant threat to the involved systems. As mentioned in the previous demonstration video, many vulnerabilities were overlapping, and so we grouped them together to streamline the remediation process. In many cases, it is possible to tackle multiple of these vulnerabilities simultaneously, often by simply updating the corresponding software to the latest version. One example of this is the Oracle MySQL server, where a majority of the vulnerabilities can be resolved by simply updating it to the latest version, which we will see in the upcoming slides. Now I'll hand it over to Galen to go over the remediation steps.
Thank you, Alec. So yeah, now I'm going to go over the first 5 remediation steps for these vulnerabilities. So first we have MS15-034, which is an HTTP.sys vulnerability. So this vulnerability allows for an exploiter to gain remote access into our systems. And this is not good, as it can do remote execution and conduct further malicious activity on our systems. So we're going to need to go ahead and install an important security update that we're missing, and that's going to be updating our Microsoft Internet Information Services, or IIS. Next, we have our Elasticsearch end-of-life vulnerability, and so this means that our Elasticsearch version has reached its end of life and it's no longer receiving vulnerability checks or vulnerability patches on its systems. So that means any number of vulnerabilities could be present on the system without us knowing. So we had to go ahead and update Elasticsearch to 11.8.11.1. Once we did this, we had to monitor these new systems, make sure everything was working correctly. Next, we had our MySQL Server security update. So this vulnerability was just another case of our servers being behind on updates. It's super common. So again, we just updated our MySQL to version 5.7.42 and got rid of any of those vulnerabilities that were present on those old systems. So the last 2 vulnerabilities I'm going to cover before I pass it over to Cassidy are going to be the Apache Tomcat end-of-life vulnerability and the OpenSSH vulnerability. So first I'm going to start with the Apache Tomcat. So this was another end-of-life vulnerability like we discussed previously. So again, the version that we had installed on our systems was no longer receiving those security patches from its vendor. So we had to go ahead and update that to the latest version, released on November 14th, 2023, which was version 10.1.16. Next, we're going to talk about the OpenSSH X11 forwarding security bypass vulnerability. So this vulnerability was not correctly handling authentication cookies for untrusted X11 forwarding, and this was allowing a malicious or compromised remote application to establish a trusted connection to your server without the correct authorization. So here we had to again update our systems for OpenSSH, and we only had to update them from 7.1 to 7.2. That shows you how crucial each update can be in protecting your systems. I'm going to pass it over to Cassidy to complete up the rest of the 5.
Thanks, Galen. I'm Cassidy. I'm going to be going over vulnerabilities 6 through 10. So starting off, OpenVAS found that there was a critical security update missing in relation to the Microsoft Bulletin MS17010. This bulletin discussed multiple vulnerabilities in the server message block, or SMB protocol. Exploitation of this vulnerability could allow access to attackers to execute malicious code or find confidential information from the server. So with this, we took the recommended action by OpenVAS and we downloaded the security update from the official Microsoft website and installed it on a machine. Our next vulnerability dealt with the Glassfish server on Metasploitable 3, and this was due to improper sanitation of a parameter in a specific file on our system. Exploitation of this vulnerability would allow remote hackers to gain access to confidential information again. Since this result on OpenVAS mentioned a specific file, which was the theme.php file, we searched for this file on the host, reviewed the code referring to the specific parameter and its input handling, and modified it to properly validate and sanitize the user input. Next, we have a vulnerability related to the SSL TLS cipher suits, which were identified on the HTTPS services. These weak ciphers found were vulnerable to the Suite 32 attack, which is a birthday attack on the 64 block ciphers that can affect HTTPS connections. This could affect communication between clients and servers on the host, but it could also lead to data leakage from successful exploitation. So what we did to fix this was configuring the SSL TLS configuration file with a text editor, and the vulnerable ciphers that were listed by OpenVAS were replaced with more secure ciphers. Now I'm going to go over vulnerabilities 9 and 10. So our next vulnerability was related to the enumeration of distributed computing environment remote procedure call and the Microsoft remote procedure call services on the remote host. The summary on OpenVAS stated that the remote host could be enumerated by connecting to port 153 and doing the appropriate queries. So an attacker could exploit this vulnerability to gain more knowledge about the remote host. What we did was create a new firewall rule with the Windows firewall settings to filter the traffic on port 153. This can make sure the traffic coming to 153 is legitimate and not a hacker trying to find information. Finally, we have a vulnerability related to the file transfer protocol. This result showed that the FTP service is allowing passwords to be transmitted in clear text, meaning plain, unencrypted text. This could be problematic because it makes them vulnerable to interception by attackers. So the attacker could sniff the network traffic to this FTP service and discover the login credentials being used. So to remediate this, we opened a terminal and opened the FTP configuration file. We configured the FTP to use SSL and TLS, ensuring more secure login mechanisms, and the FTP service was restarted to ensure it's now configured to use FTPS, which is more secure. So that's all for our vulnerabilities. Most of them were pretty easy, as Alec mentioned, just updating the correct software. And I'll hand it over to Nate for our conclusion.
Thank you, Cassidy. So to kind of talk about the state of the machine at the end of all of these fixes requires that we kind of remember how many vulnerabilities were identified in the first place, which was hundreds. And this is expected that the machine's not going to be safe after we fix, these top 10 vulnerabilities, because it was designed not to be safe in the first place, because it is a Metasploitable 3 machine. So the vast majority of these updates, as was sort of previously said, is simply going through and fixing software that is outdated, or making sure that we're pulling updates from particular pieces of software that have reached their end of life and are no longer automatically updating themselves. If we were to do this scan on multiple machines, or if we were to go down to the lower levels of that vulnerability list, we would see more vulnerabilities that have to do with particular settings of the machine or particular settings of software that are on the machine. So this is actually one of the big limitations of a sort of scan like this, is that this is only one machine that we're looking at, and it's relatively isolated in our virtual environment on our hypervisor. If we were to have multiple machines, like any organization would, You would want to test the relational settings on a network to see which machines are communicating on which ports and whether or not those settings are set in a way that is hardened and secure for the organization's needs. And sort of lastly, and most importantly, security is a cycle. So this vulnerability assessment and remediation process is something that's continuously ongoing. As software gets outdated, as hackers discover new vulnerabilities, and the updates continue to come, it's up to a network administrator or a security professional to ensure that their machines and that their networks are all in accordance with the latest updates so that you can prevent the maximum number of exploitable avenues through which someone could attack your organization. So sort of overall big lessons learned is update your machine and make sure that you're going through and setting your settings properly, and then keep doing that over and over again as you update your organization's security posture. And with that, that concludes our presentation, and we'll open the floor to any questions. Thank you.